you. Welcome to The Upgrade. I'm Seymour Segnet. Joining me as ever, Kate, you there?
Hi, I'm here.
Excellent. What do we got today?
We have a great show today that I'm very excited about. We have a cool video to show everyone. And then, of course, we have our secret word. So stay till the end. And we have a special guest today that I'm also excited about. And don't forget to, remember to subscribe and like to us on YouTube, Twitter, and Facebook. Yeah,
the YouTube button you have to smash, the Twitter you follow, and Facebook, you like us on Facebook. I've got a big idea. Why don't we have the special film and the special guest together? How about that?
Okay, yes.
Bring him in. It's Sean, who's got some fresh footage from the tooling factory. Hey, Sean.
Hello.
How are you? Now, I want to just set the scene for everybody here. We had promised you last week that we were getting a little bit of film in from the tooling factory. And to be clear before we put it on the screen, that guess who works at the tooling factory? It's really clever tooling engineers, not cinematographers, right? Like, not documentary filmmakers. Steven Spielberg does not work at the tooling factory. Okay, so it's a little shaky, but I think it'll help to give you a little bit of the flavor. So should we just let's bring it up and see what we've got? I've got it here. So this opening shot, I have it down on my screen here. So let's press play. And this, I think, is very typical of the kinds of things that they send over, because they wanted to show what a nice, clean facility, right, Sean? That's all
right.
This is showing.
Yeah, very clean. Want to make sure there isn't any debris or other particles that get into our equipment.
All right. So nice, clean facility. And here we've got an engineer. This is the easier one to understand. If I just freeze it for a second here, Sean, can we say, I didn't freeze it in a very good spot here. Let's go back a tiny bit. Right. We're sort of seeing, well, you describe it. It's two halves of the block, right?
Yes. So what we're seeing is something called DFM. It's design for manufacturing, and this is a 3D CAD file. And so that center kind of darkish pink section is what we're actually going to carve out of the metal. And the yellow and the purple on the sides are sliding actions. And so this is basically a computer model.
I'm sorry to interrupt, but that's the part right there highlighted in the middle, yes?
That's right, the pink color.
Yeah.
And this is a computer model of the part that is going to be formed by the tool. So we need to carve out a negative image of that part in the tooling. Yeah,
I mean, the expression I've sometimes used when we've been speaking before is it's the jelly mold, right? If the jelly is like this, then the mold is like that. Now, I've seen the internal model, so I have some idea what this part is. But to any reasonable person looking at it, it doesn't look anything like a charger. So what on earth is the part we're looking at?
I would not have known it was a charger at all.
Yeah.
Right. So this is an interior part. It's part of the structure or the frame, which is going to give the product a lot of strength and rigidity.
That's good.
Is that that's all you've got to say about it? I was trying to pull this one. I was trying to pull this one apart to see if we could see it in there. It's basically, I just took the back off this this model from a few months ago, and I think it's just sort of up in there, isn't it?
Yes, exactly.
It's kind of up in there, and it kind of holds a whole bunch of things together. It's also a surprisingly complex part. It's a bit of a, for the educated, and I'm not educated, but Sean is. But it's fair to say, Sean, because you've been doing this for 3 decades or something, right? That part, only an engineer who loves what he's doing would make a part quite like that. Is that fair to say?
Right. So we packed so many features into Life Charger that it took some pretty nifty mechanical engineering to fit in everything into this package, and so it presented a challenge to the tooling engineers, but they've done it, and we designed the right parts, and they're cutting out the tooling right now.
Yeah. So that's just one of how many? I'm trying to remember when we got the tooling quote in. By the way, this is one part of a $33,000 operation to make the tool just for MAGFAST Life, right? Just for MAGFAST Life. The tooling bill for all of the products is up to almost $250,000, I think. All right, so let's. But this is one of 7 or 8 parts, right? That have to be tooled.
That's right.
Something like that. All right, let's continue. All right, now what's going on here?
Okay, so this is EDM, not electronic dance music.
Electronic dance music.
Actually, electrical discharge machining. And this machine is actually carving out metal using sparks or a high voltage process. And that actually vaporizes little pockets of metal under a very controlled process.
And it's doing it under, it looks like olive oil.
Oil, olive oil.
It's not quite olive oil. It's more along the lines of kerosene. It's a dielectric, and basically it's an insulator. It prevents the electrical spark from flowing until exactly the right moment in time. And we apply the right voltage, and then the fluid becomes conductive and allows the spark to travel through to the metal.
All right, so we've all seen, welding, right, on a building site where they're joining two pieces together. So that's melting the metal to join things together. But here we're in a very localized way. We're melting it to remove a little bit, right? Because we say we're cutting metal, right? That's what we're doing here. Yes. But we're doing it. But we're doing it with a laser in a bowl of bowl of olive oil.
No lasers here. It's actually a very controlled spark, and it vaporizes a precise portion of the metal that we want to remove.
Thank you. I'm duly reprimanded. But each little spark is removing a tiny piece, right?
It's tiny, but it's actually a fairly large compared to the old-fashioned way of mechanically carving away the metal. Okay. It's a very efficient process.
All right. So let's keep going. The camera's going to pull back now, I think, if I remember how this goes. And this is, this equipment, when you were showing us to it the other day, obviously it's all computer controlled and so on, but it's not just computer controlled. It's like state-of-the-art stuff, right?
Yes, this is Japanese equipment, very precise and very efficient. It moves right along. These machines basically run 24/7, working towards. It still takes weeks, the process, because it's a lot of different parts and very precise machining.
Yeah, well, we often say, it can be quicker, but I often say it's 3 months for tooling, and whatever the period is, it's long. And it is continuous, right? It's not like they do a bit of work on a Monday and then on Thursday they do some more if they can. It's continuous.
No time off. No time off for the machines.
Right. So what's going on here?
Right. So this is a measurement machine. It has a very precise tip, and it's actually going through and measuring various elements of the tooling within very small fractions of a millimeter or an inch to just confirm that the
and there's another one.
That's right. There's several elements, and so this robotic arm, also Japanese, will switch out the parts. And you can see the shelving behind. Those are all various elements of the tooling, and this is all for life.
So all of this is for it's a very special product, but it is just one of our 6, and it's probably the smallest and least complicated of ours, isn't it?
Yeah, it is.
Yeah.
I had no idea it was that involved. I mean, I knew there was a lot of work that went into it, but this is insane.
Well, we're basically creating a mold or a tool which will be capable of manufacturing over 1 million plastic housings, which will all be at the exact right shape and right thickness. And so it does take some precision equipment to do that.
It has to be perfect.
Yes.
We said in the presentation to potential investors back on November the 19th, we're saying the thing about these, as Sean just said, right? It's up to 1 million MAGFAST lives can be made out of this tool once it's there. That's why people say, why is it taking so long? It's like you don't cut the metal until you've got everything right, because it's a give or take 3 month, $33,000, and that's just the bill, right? Let alone the time that you and I are spending on it and the meetings and all this, that, and the other. So you want to tool once and tool right. The value when we get this right, MAGFAST Life sells for $99 at retail. So potentially this is a tool that will make around about $100 million worth of product at retail prices. So it's a very, very, very serious endeavor. In fact, when you hear that, actually the tool doesn't sound so expensive, does it? The 34,000 doesn't sound so bad. So thank you, Sean, for coming in. That really helped to kind of bring it to life, which is fantastic. Send us your questions. Any questions you got about that? We'd love to answer them for you. Pick our brains.
Don't forget the secret
keyword, and then let everyone get on their way.
Yes, Sean, what is the secret keyword this week?
This week's secret keyword is tooling.
Brilliant. Brilliant.
Easy to remember.
Easy to remember. Link down below. Click on it. Enter tooling. 3 extra chances to win in this month's $1,000 draw of gorgeous MAGFAST stuff and other electronics. You work with Kate to make a selection that delights you. And Kate, we really must announce the recent winner next week. If you don't have it in front of you now, do you?
No, I will have next week though.
We'll bring it in next week. I think that's it. Thanks for joining us, Sean. Will you come again soon, please?
Sure thing.
All right. Bless you. Thanks so much. Thank you for helping us change charging for good.